So we have 14x minus 70 equals 11x minus 22. And then when we finish it up, we get 3x equals 48. I'm not going to spend a lot of time with this part. I'm just going to go to here and say x equals 16. Now, how do you check your answers? Yeah, because sometimes you'll have an extraneous answer that doesn't work, so you want to check it. Like if you get a number that's going to make your denominator 0, that's a problem, correct?
Yeah.
Okay, so that's when it doesn't work. So 16 minus 2 doesn't make it 0, does it? 2x, 32 minus 10 doesn't make it 0, so we should be okay. That's really what you're checking for. Okay? All right, this one as well. Why don't you try it real quick? Try not to have a negative leading coefficient. Move your equation around so your 2x squared is not negative. It's easier that way. There's the beginning of it. I didn't finish it yet. It's easier if you move this equation around so this is not negative. Okay? Now I'm going to pull out a 2. See where I'm at? X is equal to 4 and negative 1. I don't know how I did that. It's supposed to be minus 3. Just checking to see if you're awake. Yeah. Because you set each of these equal to 0 to see what x would be. Okay? All right, now just stop and take a second and say, if I plug in 4 to this denominator, it won't be 0, will it? I mean, that's the most important thing you're checking. You could go all the way just to make sure if you plug in 4 in here and 4 here, you have equal fractions. You could do that. But really, you're just checking to make sure it doesn't make that denominator 0. Because then it's not legit. Okay? And these both happen to work when you plug them in. All right. All good with that? Okay, let's do some more. All right, solve the equation and check for extraneous solutions. So, what you really want to do is you want to look at the denominators. Oh, sorry. And this just has a 1 in the denominator, right? So you really don't need to think about that too much. You want to look at these two denominators. What would be the least common denominator, or the word least common multiple of those two? 2x, correct? I'd have to multiply this by x. I have to multiply that. So it's 2x. So what you have to do is you got to multiply everything here by 2x. Which isn't too bad. So I'm going to split it up. I'm going to say, okay, I have 7 over 2 times 2x plus 3 over x times 2x equals 3 times 2x. And what happens here? The 2's cancel, correct? Can you see it? The 2's cancel. So I'm just left with 7x plus the x's cancel here. So I'm left with 6 equals 6x. Look how pretty that is. Not so bad. Okay, and then you just finish it up. So 6 equals negative x. Divide both sides by negative 1, x equals negative 6. Okay, now if I plug in negative 6 up here, I'm okay, aren't I? It's not 0. So I should be all right with that. Now you could take it further and you could say 3.5 plus negative 1/2 does give me 3. That's true. Okay? All right, let's do another one. So again, for this one, 1 just has a denominator of 1, so I'm looking at x plus 7 and x. Okay? The common denominator would be what? X times x plus 7, correct? So I got to multiply all of this by x plus 7 times x. So let's write it out small. 12 over x plus 7 times x plus 7 over x, or times x. That's the first one. Equals, what's 1 times that stuff? It's that stuff, isn't it? 1 times that stuff is that stuff. So I'm just going to write that, like right there for 1. Minus 12 over x times x plus 7 times x. Okay. Now we simplify. So here x plus 7 cancels out, doesn't it? And I have 12x equals, I'm going to multiply this through right now just because I can, x squared plus 7x minus, and the x's cancel here. I got to be careful because I have a minus I'm working with. So I'm going to put a parenthesis, and I'm going to multiply 12 times x plus 7 right away here. So it would be 12x plus 84 inside of here. I'm going to stop and make sure that you all see where I'm at so far. Questions? Doable? Okay. Now we just got to go through and simplify. So, let's see. I think I distributed that 12, that negative. I can combine these two and set it equal to 0, but I always take the long way. So there we go. Combined 7 and negative 12x. And then I'm going to subtract 12x from both sides. Hold on, I did something wrong. Yeah, but if I subtract 12x, I get negative 17x, which is not what I started with. But let's just do it. Okay, let's just do it. Right? Okay. So my solutions would be positive 21 and negative 4. Then I go up here and I say, okay, 21 plus 7 is 28. I should be okay there. It does not give me a 0 in the bottom. And negative 4 here, I should be okay there. We could check it out. We could go all the way if we want to and just make sure, but it's true. It's 12 over 28 equals 1 minus 12 over 21. And you end up being all right when you do it. So, okay? She's not happy, is she? Yes. Okay. So just a few more here. Same thing, basically. What is a least common denominator here? 2x times x plus 1. How you feeling so far? You feeling pretty good about this? It's not bad. So I'm going to multiply each thing by 2x times x plus 1. If I look at this first one here, and I multiply that times that, the x plus 1's cancel out, don't they? So I'm just left with what? 6x squared. Not too bad. Minus, and I look at the middle term, and the 2x's will cancel out, and I have 5 times x plus 1. Correct? Oh, I'm going to put the 5 out here. X plus 1, sorry. It's kind of messy. That's minus 5 times x plus 1. Equals 3 times x plus 1. And then for the sake of time, because I'm making Dan sleepy, I'm just going to kind of go quickly through this. This is what it would look like when you take it to set equal to 0. I think you can get to that point. And then I can divide out a what? A 2 from each term. And then what would you have to do to factor this? You'd probably use a what? A box. And when you do that, this is what you get. And then ends up that x is equal to negative 2/3 and x equals 2. We're going to see an extraneous solution in a minute. I'm just going to let you know that. Okay, so we're good with those two. Neither one of them are extraneous. So I don't know if I'll work through this whole thing, but I do want you to consider the common denominator. This is x plus 1, and this could be written as x plus 1 times x minus 1. So what would the common denominator have to be? It'd have to be both of these things. It'd have to be both of these, right here. Okay? Because there's x minus 1 here and x minus 1, there's x plus 1 here, so I got to make sure that's included in my common denominator. So then you would just multiply everything by x plus 1 times x minus 1. Just like we've been doing. Yes, Darby. No, because they're both here, so you just take one of them. Okay? But this doesn't have anything else, so it's got to go with you too. Okay? And then that would cancel that out, and we'd cancel the denominator out completely on this side, and it turns out to be kind of pretty. Because this has to be part of the denominator, because it's not over here. Like, see how there's two x minus 1s? That has to be part of the denominator, but only one of them. And since this is here, it also has to be part of the denominator. Just like here, 2x had to be part of the denominator, but only one time. Okay? All right. You can come and see that finished if you want, but let's do this one. That's not too hard. What's the common denominator here? X minus 2. So I'm going to multiply everything times x minus 2. This one's a pretty quick one. The first term here on this side becomes just what? 5x plus, equals 7 times x minus 2. And then this term here just becomes what? 10. And then what happens is you get this. 5x equals 7x minus 14 plus 10. And when you do the math, you get this. X equals 2. Uh-oh. What happens when I put 2 in here? Yeah, it's not so good. You get a 0 on the denominator. So this is an extraneous solution. It doesn't work. Which I'm guessing would mean you would have some sort of imaginary solution. I don't know. That's next year. Okay, this is really easy story problem. Let's just take a look at it. It won't take long. A company produces computer desks. The average cost, this is C of x, to produce X desks, this is X desks, and cost of desks, can be modeled by this function. How many desks should the company produce each month in order to achieve an average cost of $85? So that's my average cost, which is my C of x. That's my C of x. So all I have to do is plug that into the function where C of x is. And there's really nothing tricky about this. You have to get rid of x in the denominator. What would you do? Multiply both sides by x. So that's all you kind of get going on that by multiplying both sides by x. 85x equals 4,000 plus 50x. 35x equals 4,000. and X would be about 114.286. Well, you can't have 0.286 desks, so it'd be about 114 desks. See, that wasn't so bad.